In this video, we will go over kinetic and potential energy. Okay, so our problem for this is we have a ball that is thrown upward with an initial velocity of 15 meters per second. We know the mass of the ball is 2 kilograms, and we want to find out what is the change in kinetic energy and the change in potential energy from when the ball is thrown to when the ball reaches its maximum height. So for this, the ball is going to start going upwards with a velocity of 15 meters per second, and due to gravity it will slow down and slow down, eventually reach its maximum height, and that'll be our end point. So some given information: we know we have a mass of 2.0 kilograms, our initial velocity is 15 meters per second, our final velocity should actually be 0 meters per second, because at the maximum height, the ball should not be moving. So our final velocity will be 0 meters per second. And we have to define where our height is at. So we'll just consider the initial, where the ball is thrown, that to be 0 meters, that to be at, I guess you could say, the ground state. And now, if we're going to find kinetic energy and potential energy, we should probably have a mathematical way to find those. So kinetic energy is equal to 1/2 multiplied by mass multiplied by velocity squared. And potential energy is equal to mass multiplied by acceleration due to gravity, so that's g, multiplied by the height. Okay, so let's go ahead and just start off by trying to find the change in kinetic energy. So our change in kinetic energy would be equal to the final kinetic energy minus the initial kinetic energy. Now we can go ahead and even rewrite this and simplify it further by saying the change in kinetic energy is equal to 1/2 multiplied by the mass multiplied by the final velocity squared minus 1/2 multiplied by the mass multiplied by the initial velocity squared. So now we can go ahead and plug in our values that we know here and solve for our change in kinetic energy. And that would be 1/2 multiplied by our mass, which is 2.0 kilograms, multiplied by the final velocity squared, which is 0 meters per second, and that's squared, minus 1/2 multiplied by 2.0 kilograms multiplied by 15 meters per second, and that's squared. So if you work that out, that ends up being, let's see here, a negative 225 kilograms meters squared per second squared. Now those aren't really units we'll want to use, and because we're working in energy, your first thought might be that we'll use the unit of joules. And so you think, well, how do we come up with that? Well, 1 joule is actually defined to be 1 kilogram meter squared per second squared. So really, if you think about that, all of those units cancel, and our change in kinetic energy is really just negative 225 joules. Now this is a very simple unit conversion, just because of the way the SI unit system is based and how joules uses all of these base units. So if you weren't using a base unit, like let's say of kilograms, let's say you're using grams, you would have to convert to kilograms in order to easily make this unit conversion. Now, to find the change in potential energy, we have to know the height of the ball at its maximum height, which we currently don't know. So I'll actually use a kinematic equation, one of those constant acceleration equations, to find that. So I'll start with the this one, because it looks like it has all the variables we will need. Let's see here. And that is the final velocity squared is equal to initial velocity squared plus 2 times the acceleration multiplied by the quantity x minus and the initial x. And those are distances, the x values are. So if we kind of rewrite this in terms of what we are dealing with, we still have a final velocity squared. We have our initial velocity squared. Now instead of saying plus 2 times a, I know that our acceleration is downward because gravity is downward. So I'll go ahead and just make that a minus 2g. And then instead of x minus x0, we'll use our final height minus our initial height. Now, really we just need to solve for the h sub f, or our final height. So we can subtract the initial velocity squared from each side. And it should leave us with this equation. Now I'll divide by a negative 2g on each side of the equation. And then I'll go ahead and add your initial height to both sides of the equation. And that should end up giving you, let's see here, that should end up just giving you your final height. So let's go ahead and plug in for that and solve for that. We have our final velocity squared. Our final velocity should be 0 meters per second, that's squared, minus 15 meters per second squared. That's over negative 2 times 9.80 meters per second squared. Plus your initial height, which is, we're just going to have as 0 meters. So if you work all that out, it should come to be about 11.5 meters. So 11.5 meters is how high the ball will go during all this. So let's go ahead and now try to find the change in potential energy. And we know that's just our final potential energy minus our initial potential energy. So if we try to expand this a little more, we have our mass multiplied by g multiplied by our final height minus mass times g times our initial height. So change in potential energy will become 2.0 kilograms multiplied by 9.80 meters per second squared multiplied by our final height, which is 11.5 meters, minus the 2.0 kilograms multiplied by 9.80 meters per second squared multiplied by our initial height, which we defined as 0 meters. So really that last term, our initial potential energy, should be 0, which makes sense since we're defining it as the ground state. So if you calculate this, you should get it to be 225 kilograms meters squared per second squared. And just like before, we know that 1 joule is the same as 1 kilogram meters squared per second squared. So all these units actually reduce, and you get your change in potential energy to be 225 joules. And so when you look at these two answers, you might think, well, this is something funny. They're kind of the same number, it's just one's a negative and one's a positive value. And the reason for this is because at the ball's, I'll try to go ahead and draw a picture here. At the ball's initial state, we'll say that's ground state, so that's your initial height is 0 meters. It also has an initial velocity of be 15 meters per second. The ball has kinetic energy, but we've defined it to have no potential energy. And when the ball is at its maximum height up here, because the final velocity is 0 meters per second, it has no kinetic energy, but its height is 11.5 meters. It has only potential energy. So what has really happened here is we have a ball with only kinetic energy, and all that kinetic energy is starting to be transferred to potential energy, and then the kinetic energy runs out at the maximum height, and that's where we only have potential energy. So all the kinetic energy is transferred to potential energy here. And this has been a video over kinetic and potential energy.